Hello. Hey, everyone. Yeah, I'm with the Ethereum Foundation, Privacy and Scaling Explorations. We do a lot of like ZK and now recently more MPC and FHE research and trying to build applications that can be used by anyone. I work in MACI and we deal with private voting. So today we're just going to be going through MACI and just dive a little bit into the protocol, nothing crazy, and kind of focus on how you can build on it and what you can build on it for the hackathon. Right, so MACI is a private voting protocol. You can use it to run like on-chain polls. These are the main properties. So collusion resistance. You basically you have a coordinator role, and only them can be certain of the validity of a vote. So collusion becomes very difficult. You also cannot prove how you voted because all the votes are encrypted, and for you to prove beyond a reasonable doubt how you voted, everyone would also need to show the vote, or the coordinator in this case. It's private. Only you and the coordinator really know how to decrypt your vote. It cannot be censored, so every vote that is sent on chain must be processed and cannot be censored even by the coordinator. You can alter your vote, you can nullify your votes, but you cannot really delete it. Once an action is posted on chain, it's there and it must be processed. And the coordinator cannot really produce any false output, and that's thanks to the ZK stuff. Cool. So why do we need private voting? I mean, I think in general, voting is just susceptible to bribery and collusion. We've seen it everywhere, whether it's like local election or like online voting. With quadratic funding and quadratic voting, for instance, the difference can be made by more people actually coming together and voting for a project or contributing a small amount of money compared to like more organized group with money. But if collusion is easy, then still we don't really solve the problem there. Yeah, also when you're voting, like if you know everyone voted, you might get conditioned, right? Maybe you don't research too much on the candidates or the projects. You're like, okay, this famous person is voting on them, let me just do the same. And yeah, just to reiterate on the bribery part, like because with MACI, the briber cannot really be sure of how you voted, then they wouldn't really have a reason, motivation to bribe you. And the goal is to bring more democratic voting. So the architecture, the protocol is divided into like three main parts. We got the smart contracts, which run on any EVM chains. We got some ZK circuits. These are built with Circom. There's like these two big circuits. One of them deals with processing the messages and generating proof that everything was done correctly. And the tally one, which basically sums up all the votes and generates what we call the results of the voting round. And you'll find a bunch of like TypeScript code that basically replicates some of the logic of the smart contract, so it can be process of chain and like an SDK to interact with it. So the user flow, kind of simplified. You as the user, you can register into the system. You register with your own identity. This is a MACI public key, which is not to be confused with like an Ethereum key. This is like a DDSA key, and you basically just need to pass some set of conditions that's decided by whoever runs the voting round. Maybe prove you're not a Sibyl, prove you own something, anything they want. And once you register, you can send votes. These votes are encrypted, and they are encrypted with a shared key between you and the coordinator. And they're also signed with your own private key, so that no one else can really like post votes on your behalf. After all the processing, then like you can verify. So like the protocol is fully verifiable. You'll have the public data of the tally, and you can just verify on chain. Just to dive a little bit into the vote itself. So that's like a encrypted command that is sent to the smart contracts. It is encrypted with the share key. We use a CDH, so you generate a random key. The coordinator has the public key on the smart contracts, you generate a share key, you encrypt it, and then you send an encrypted vote, then the coordinator can just reverse the process. You sign it with DSA, as mentioned before. There are some nonces on the messages so that you can send different votes, and you can create like your ballot through the different votes. And you can also use the nonce to invalidate previous votes in case, I don't know, you made a mistake or like you think you're bribed and you just want to invalidate everything that was sent before. In the message, so this vote, you specify who you're voting for, which is like the vote option, the weight, so there's like quadratic voting and non-quadratic voting. You have a certain amount of credits to spend, and you just basically like weigh your preference through the vote. It can also be like a simple like yes or no vote, but yeah, it will still go through the vote weight. It'll just be like 1 instead of like a different number. Yeah, basically anyone can vote really, but only if you signed up, your vote will be counted. So like that kind of adds up to the anonymity set. So you just sign up, maybe one address, then you go and vote with a different Ethereum address. And as long as you have this MACI key and you sign the vote with it, then you'll be able to cast valid votes. So this is what the coordinator does. So yeah, we have the poll, this finishes. Users are not able to send any more messages. We have this like Merkle trees on chain. We just merge the data, store whatever we need. We pull all the events with this TypeScript code, and then we basically run the processing. So the processing is like decrypting the votes by the coordinator and constructing a ballot based on the valid votes, and then put all this data into like a ZK circuit, generate proofs, and just submit them on chain. Everything validates on chain. That's cool. We can then do the tally. So we have all the ballots. Well, the coordinator has all the ballots locally. And again, process them, calculates the result, the tally, and then generates proof and posts them on chain. There are some trust assumptions. Currently, there is like a coordinator figure, and it is assumed to be honest. They could publish these votes. They could decide just to not conclude a round, or maybe just delay, or they can collude themselves with bribers. What they cannot do is they cannot really censor any votes. I mean, if the code is audited, if the code works correctly, they cannot do that. Everything that is sent on chain must be processed. And they can also not do any incorrect processing of this data because they need to submit ZK proofs for it. Yeah, so what helps here is like this source of truth that basically form the public inputs to the circuits. So everything that is stored on chain, like number of votes, number of people that sign up, all of this goes into like the public inputs to the circuit. So if the coordinator is trying to like process less messages, censor some users, they just won't be able to verify the proof on chain, and people will know that there's something wrong with this round. Cool. So now on the hackathon part, what can you build with it? There's a lot of things. I say that you can build different integrations. Yeah, something like we've not explored yet is like building tooling for DAOs, so like for DAO voting. That kind of has a few problems, like how do you assign the credits for voting? Like, you know, I mean, maybe in a DAO you'd have like power based on the tokens you hold, but you know, something to keep in mind is like flash loans and stuff. So if someone wants to tackle this, that'd be pretty interesting. There's some like protocols that we'd like to integrate with, like Anonadar or Open Passport, and this can be used for like gatekeeping access to the voting round. So let's say only Indian residents with Anonadar can like join the round, or like with Open Passport, whatever passport they support, you know, that's how you could filter civils. Some other ideas like building some voting app for like university clubs, sort of election system, like feedback as well. I think you could have like internal feedback system built with MACI, build apps, like we're just starting to explore a kind of abstraction, which is what we kind of need to be able to bring this to the masses. and building an app that has like paymasters, like custom one maybe they just allowed users to like vote or sign up, like you cannot reuse these paymaster for the stuff, or like they maybe limit the amount of like transaction that can be made and whatnot, and smart wallets for recovery so that anyone that doesn't really own a MetaMask wallet or any other wallet can actually use these apps. Some other cool stuff would be trying to make it completely free, so like maybe build some sort of like relay system that can be used to relay votes and messages on chain. And some other ideas like build like a recursive MACI, so thinking like some sort of like tournament style voting, where like you started like I don't know, there's 8 projects, and then the top 4 make it to the next vote, and like trying to build like an app and like starting the vote based on these results. Things that I'd like to see personally, and I think will make stand out some projects, is like trying to implement some sort of new voting methods. Like that can be done through changes in the tally circuits. So for instance, like capping the max vote that can be assigned to a project or to an option, or maybe just like having only 2 winners instead of more, and whatever you can think really, any other type of like voting that is just not the simple quadratic voting or non-quadratic voting. Yeah, some other stuff would be like building, if you build an app, it would be really cool to see like some sort of widget, like for like the quadratic voting part, which I think people find quite hard in terms of interface. We've seen like people trying to spend the credits, and they're like, okay, I'm putting 10 credits, but why is it counting 100? If you have any idea on how to do this, that'd be really cool to see. And yeah, mentioned before, like some custom paymaster stuff. So how you can build on it? So the core protocol is here on this repo. That's where you find the smart contract and the circuits. Then we're starting to build like a platform, which is like basically like a front end with some automation for the coordinator stuff. The coordinator stuff not really ready yet, but the front end is, and there's like it can be used, can be forked, can be changed, and it'd be great, to like maybe start from there rather than starting from scratch. Or there's also like a community build project that came out of like ETH London hackathon. And yeah, it's like a wrapper, like it's built using, what's that called? ETH, from Bill Guild, I can't really remember. But anyway, like you can use it to like very easily create like polls and like, yeah, build on MACI, like very easily. So yeah. We have a few bounties. So the first one will get 3,000 and some DevCon tickets for free. Yeah, so exciting stuff. 2,000 for the second and 1,250 for the third. There's 2 more. Just I didn't have a medal emoji for it, but there's 2 more prices, like 750 and 500, I believe. Yeah, I mean, just to reiterate, like, we really think that tackling voting issues is important, and yeah, we think MACI like makes this more secure. It's far from perfect, and yeah, that's why we kind of like try to come to hackathons, so like encourage people to contribute to the project. Everything we do with PSE is like open source and public good. So if it's not today, it's another time you guys wanna pop by Discord and like trying to contribute on something. We really welcome people to help. And yeah, just some links and stuff to join the PSC Discord. Like we got a public channel there, you can ask questions. I'll be around the venue, so like you can drop a text and then, like we don't have a booth, but drop a text and then we'll meet somewhere. I'll be happy to help. Yeah, just some links and stuff. I'll share this in the Discord later. Yeah, that's everything. If anyone's got any questions, we got some time.
Quick question. I need to understand who is the coordinator. I mean, if I, for example, create a voting system, I am the coordinator, or is it
Okay, that's a good question. So to answer the first one, you can choose who the coordinator is. Like, so the terminology would be like you, the one that deploys the contracts and operates the round or the voting, is like an operator. And then the coordinator is basically like a key. It's like a key pair. So like, you could appoint someone that generates this DDSA key. They publish the public key on chain with a poll. And then, they are in charge then of processing everything at the end. So it doesn't need to be yourself. It can be someone else. And yeah, so we don't really have any slashing mechanism for it. I mean, that'll probably be something cool to implement. Yeah, like even like MPC is not something we've really explored that much yet. But yeah, like anything that can reduce the trust of the coordinator would be like great to see. Okay. Sure.
How is the proof usually stored on chain? So for example, does that make sense to use Ethereum attestation service to let the coordinator create attestation and hash the proof, or there are better ways to do it?
To like submit the proof, you mean? Like to store it?
How to hold a CK proof on chain?
How do they say proof? Yeah, so basically like there will be like this tally file, which like is basically like a file with the result and some sort of commitments to the data that should be made publicly available. For now, it's just like a JSON file. We didn't really think about where to put it. It's just up to the operator coordinator. But yeah, that's a good point. It could be part of the data of a ES. And yeah, user would take that, run through. There's the CLI command that you can use to verify this data on chain. Yeah, but that's, good question there, yeah.
All the MACI public keys
Yeah.
registration, they are written locally on the client side.
Yeah.
And then they are registered in the local tree on smart contract, or how is it registered?
Correct, yeah. So basically, you'll create the key yourself. It can be done deterministically. So like, like you don't want to remember like the secret to it. You can use like your wallet signature, for instance. Sign a message in the app, and that generates like with the hash of that. You can use it as seed for the key, and then yeah, basically you submit the sign up transaction chain, and your key alongside with your public key alongside your credits will be stored into like what we call a state leaf, and that goes into like the state tree, which is just a medical tree, yeah.
So it should be quite easy to just limit one key to each person in the DAO.
Yeah, so that would be up to the gatekeeping mechanism, like let's say Anonadar, right? You scan it once, and through the gatekeeper, we recorded this Anonadar ID or whatever is being used, and you cannot use it again, right? Unless you have someone else's card or like with a passport. Yeah. So that's custom, like yeah. Cool. I think it's 50 past. Any more questions? We can talk later. I'm on Discord. There's a channel in the ETHGlobal one. Just drop a text. Yeah, I'll be happy to talk. And yeah, thanks for listening.